For number 12, we have a patio that is against a house and you want to put a fence around it, but because the patio is up against the house, you don't need to have 4 sides of the fence. You only need 3. So this is our patio, and only 3 sides need to be enclosed because the side of the house is acting as one side of the fence. All right, so you have 40 feet and you want to maximize the area of your patio. You want to get the biggest amount possible with that 40 feet of fence. You need to figure out the dimensions to cut each side. So we're going to do a maximizing problem, and we're going to set up a function that represents the area based on that first side of the fence that you cut off. So I take my 40 feet and I'm not sure what to cut off, but I'm going to cut off some random X amount for the one side, and I'm going to just say that that's my length. And then if that side is some X amount, then on the other side, which is exactly the same, I'm going to have to cut the same amount for that. So if I start with 40 feet, maybe I cut 5 feet off. That means I have to right away cut another 5 feet for the other side. Or if I cut 7 feet off, then I have to cut 7 feet off for the other side. Now to get whatever's left over for this last edge, no matter how much you decide to cut off at first, you're going to take the full amount of 40 and you're going to subtract off those 2 amounts. And 1x plus 1x would be a total of 2x. Whatever amount I cut off, I'm cutting off double that. So 40 minus 2 times my first cut gives you the leftover, and we'll call that the width. And then once you do that, you can now make your formula. Now that you have algebraic dimensions on your rectangular fenced-in area, you can make your function area of a rectangle is simply equal to the length times the width. And my area, if I write it function style, with respect to the amount that I cut off, that X amount, is equal to my length, which is X, times my width, which is 40 minus 2X. So area is length times width. My length is X. My width is 40 minus 2X. And then I'm going to go ahead and distribute my X. Since we're using a graphing calculator, you don't really need to distribute, but I'm going to distribute it anyway. And I get 40x minus 2x squared. And then I'm going to write that with my x squared term first. And I get negative 2x squared plus 40x. So my area formula or area function based on whatever x I cut off is negative 2x squared plus 40x. Now I know that a negative x squared equation is going to give me a parabola, and it's going to give me an upside down parabola. And the parabola is going to look something like this. And what you need to do is put that into your graphing calculator and figure out this max point. That max point is going to be your length that you're cutting off. As well as the area or the max area. That's what it's going to give you. The x coordinate tells you the initial length that you should cut off to get the biggest area out of your rectangular fenced area. And the x that you cut off is going to tell you the X value is going to tell you what you need to cut off initially to get the biggest area possible with that amount of fence. And when you put this into your graphing calculator, you probably aren't going to see the entire graph, and you're going to have to fool around with your window dimensions and zooming to see that maximum point. If you know the domain of your function, that will really help you figure out at least how far left and right to go with your graph. And the domain would be the x's that I could initially cut off for that first length. And so if I figured out my domain ahead of time, I need to cut off at least something. So I can't just cut off nothing, or I won't even be able to build the fence. It'd be a side of 0, and that doesn't make sense. So the x has to be greater than 0 that I cut off. And the maximum amount that I can cut off would be the upper end of my domain. And if I try to cut off 30 feet of fence, then I would need to cut off 30 off the other side. And 30 and 30 is 60. I don't even have that much fence. If I try to cut off, like, I don't know, 25 feet of fence for the first cut, because I have 40 and I make a first cut of 25, then the other side would have to be cut 25 as well, which sucks up 50 feet of fence, and I don't even have that. So the maximum amount of fence that I can cut off would actually be less than 20. Because if I cut off 20 feet over here, and then that means I'd have to cut off another 20 for the other side, that's exactly 40, and I have nothing left over for the width. So the maximum that I can cut off can't be exactly 20, but it has to be less than 20. So by knowing my domain and the x's that I can actually cut off for the fence, I can set this window range for my x min and then my x max right here between 0 and 20. Now the area is going to be a little bit tricky. So let's say I cut off, 20 feet, then like 20 by 20 would be 400. So I know at least my maximum area has got to be less than 400 feet. So I'm going to go ahead and put into my graphing calculator number one, my equation. I'll go into y equals and do negative 2x squared plus 40x. Not only put that in, but put in my window dimensions as well. My least amount of x that I can cut off has to be bigger than 0. I can't cut off more than 20 because that wouldn't leave me anything for the third side of the fence. My area is going to at least be something, so it's going to be bigger than 0, and then my max area is probably going to be less than 400. And so I'm going to actually set my max, instead of being 400, I'm just going to set a little bit lower at 300, and then take my chances. If my graph window isn't big enough and it cuts off the top of my graph, I'll just increase that y max a little bit. So I'm going to hit enter and then graph. And that looks actually pretty good to me. I can really zoom in nicely into that max right there. And I'm going to go ahead and find it. Do second calc. And then max is 4. And then I need to do left bound. So be to the left of your max. Then we're going to go right bound. I'm probably going too far left and right, but I just want to be safe. And then I'm going to try to get right on top of that hill, on top of that max point, and hit enter. And my calculator, gives me nice exact clean numbers, 10 and 200. So if I come over here, then my x coordinate was 10 and the y coordinate was 200. So my dimensions to maximize the area within that fence is going to have a length of X, which is equal to 10. The width is equal to 40 minus 2x, or 40 minus 2 times 10, which is 40 minus 20, which is 20. So the dimensions are 10 by 20 in order to get a max area of 200.